In this video, we're going to take a look at solving for x and y intercepts. The big deal, you guys, for solving x and y intercepts, and I put that on the top of this sheet, is that you plug 0 in for the other letter. Anytime you're looking for an x and y intercept, just simply plug 0 in for the other letter. You're zeroing it out, and you're going on the axis, and you should be able to locate where that is. So then what you're going to do for this one is we'll go through number 1 together, and then I'll ask you to do number 3. Number 2 needs to be factored before you can do it. Number 4 already is factored. Number 3 is already factored. So I'll show you how to deal with the kinds that are already factored and not factored. So let's take a look at that then. So for this first one, number 1, the equation was y equals 3x squared minus 2x minus 5. Well, the y-intercepts are the easiest. The y-intercepts are easier because all you got to do is plug 0 in for x. If I put 0 in there and put 0 in there, guess what? Those all cancel out. And what ends up happening is you take 0 times this, and it ends up being, well, the negative 5. The constant on the end, that number that remains in the end of this problem, is the y-intercept. We write that as an ordered pair. X, 0, y, negative 5, 0, comma, negative 5 is the y-intercept. 0 these out. Goodbye. It's negative 5. Next, x-intercepts take a little bit more work. The work that they take is you plug 0 in for y, so the 0 goes over here. Well, then you end up with this thing. So when does all of this equal 0? Well, the only way to figure that out is to get it to look like this. So you need two parts that are factored so that when you have the two factored pieces, you can take these two pieces and you can split them up. And you can take this first piece, whatever it is, and set it equal to 0. Take the second piece, whatever it is, set it equal to 0, and solve those little two baby equations. Well, in order to get these written like this, you have to factor it. So you go back over here and you put the first number, which is the 3x squared, in your corner, the negative 5 in the other corner. You multiply those together. That's the top of your diamond problem. Then the middle number, this 2x right here that we haven't used, goes in the bottom of your diamond problem. All right? Multiplies a negative 15, adds a negative 2. That's negative 5 and 3. Those two numbers are the missing ingredients that go back into your diamond problem. Then you find the distances on the outside that would make that work. And so then the dimensions would be, this would be 3x times x makes 3x squared. Then this would have to be plus 1, because that's the only way that will work. If that's the case, then this would have to be negative 5. Negative 5 times x is this. Negative 5 times 1 is 5, and that all works. So our two factored parts are 3x minus 5, because that's the dimensions of this side of your generic rectangle, and x plus 1 over here. Now once we have it factored, we can do little two baby equations. When does 3x minus 5 equal 0? When does x plus 1 equal 0? Now to solve these, do what you've been doing to solve equations. Subtract 5 on both sides. 3x equals negative 5, divide by 3, and x equals negative 5 thirds. That is one of the x-intercepts. So negative 5 thirds, comma 0 is one of them. Subtract 1, x equals negative 1, so negative 1, comma 0 is the second x-intercept. So for this particular problem that looks like this, the y-intercept's easy. You just plug in 0 for x, it all zeroes out, you get negative 5. The x-intercepts take a little work. You've got to have this quadratic written as a sum, then you write it as a product, so it's two factored parts, and then you can set those two parts equal to 0. But in order to factor, you have to know generic rectangles and diamond problems, and then you set each of those little pieces to 0, and you get these two solutions. So the two answers for the x-intercepts are here, and the y-intercept is here. One thing you can do is you can type this equation into your graphing calculator. When you type it into your graphing calculator, you can then do different things like we talked about in class, where you can do graph, and then you can trace, and you can have it calculate the point of intersection. I can see where it hits the x-axis. As long as I have my second equation at 0, I can go second calc, and I can have it calculate number 5, which is the intersection point, and I hit return 3 times, and it starts flashing there, and it says negative 1, 0. We knew that already. Then I can do trace, and I can go over to this area where the second one is, and I can go second calc, go down to the fifth option, number 5, hit enter, keep hitting enter until it shows up, and it's 1.6 repeating, comma 0, and that's the other answer that we had. That 5 thirds is 1.6, comma 0. Now, now I just caught my mistake, because to get rid of a minus 5, I need to add 5 to both sides. That was my mistake here. So this should be plus 5, plus 5, plus 5 all the way through. So that should have been a positive 5 thirds. So it is nice, I guess, to check your work with the calculator, because you can actually see that the graph hits one time on the negative side and one time on the positive side. All right, then the only other thing I want to look at here on this worksheet is number 3, because number 3 already gives it to you in factored form. Number 2, you have to factor and figure it out. Number 3, it's already factored. So you should know that you can just split that into 2 to find the x-intercepts. There might be a little bit of a trick to find the y's, but the y's are so easy because here is what number 3 looks like. And if you can plug in 0 for x, then you can find the y's. And these are 2 numbers that you need to multiply together once you do that. So go ahead and pause the video, see if you can work through this problem before I show the solution, and then you can check it. So go ahead and pause. Okay, welcome back. Here's what we have. We've got 0 plugged in for x. That 0's this piece out, 0's this piece out. 7 times negative 5 is negative 35. 7 times negative 5 is negative 35. That's the y-intercept. 0, negative 35. The x-intercept, these pieces, you guys, are already factored. So I can just split this into 2. Take this piece and set them equal to 0. So that's what I did. 2x plus 7 equals 0, or 5x minus 5 equals 0. Walk through it, both sides solving. You get negative 3.5, 0, and you get 1, 0. So when they're already in factored form, it does speed up the x-intercepts because you don't have to factor. You should be able to finish the rest of the questions on the worksheet. If you need to go back and rewatch parts of this, that's fine.